So chapter 4.2 gives us this word problem that says find the area of a parallelogram bounded by the y-axis, the line x equals 6, the line f of x equals 2x minus 4, and a line parallel to f of x that passes through the point -2, -6. So the first thing we want to do is just sketch out a picture of this on a graph. Then we have, since this is the x-axis, this is x equals 0. And then we have another line, x equals 6. Then we have this f of x, which is defined as 2x minus 4. And then we have one more line that's parallel to that. So if this is f of x, then let's call the parallel line g of x. And the way to write a parallel equation would be to take the same slope, which is in this case is going to be 2. So it's 2x, and then we're going to solve for a new b. So since it passes through this point, we can plug this in to find the equation. We have that our y, or our g of x, is -6 equals 2 times -2 plus b. And then if we solve for b, it comes out to be -2. So then our g of x is going to be 2x minus 2. And if we look at it on the graph, it's going to look something like this. So g of x equals 2x minus 2. Now let's define our points on the graph. We have this point, and this point. And these are the vertices of our graph. So let's call this A, let's call this B, let's call this point C, and let's call this last point up here D. And we want to try to define these points first. It's going to help. So we have A at, and it's going to be 0, -2. And we can easily just see that because it's the y-intercept of this g of x. And then B, similarly, is going to be 0, -4. So for C, we want to find where this f of x, 2x minus 4, crosses or intersects with the line x equals 6. So essentially, we're just plugging in f of 6, which gives us 2 times 6 minus 4, and this comes out to be 8. So the point C is at 6, 8. And then finally, D is going to be the same thing. We're going to find where g of x intersects with x equals 6. So we're going to put g of 6, and this gives us 2 times 6 minus 2. This comes out to 10. So D is at 6, 10. We know that the area of a parallelogram is defined as base times height. So if we look at a parallelogram here, this is our base, and our height is going to be the distance from that top line to the bottom line, the distance from the top base to the bottom base. So in this case, let's call BC our base. So B is our line BC. And then for our height, we can define two other points here, call them E and F, which is going to be perpendicular to both of these lines here. So our height is given by the distance between E and F. So to find our EF, let's write an equation. Let's call it h of x. That's perpendicular to g of x and f of x. So we know that if it's perpendicular, the slope is going to be the negative reciprocal. So in this case, since g of x and f of x both have a slope of 2x, then our h of x is going to be -1/2 x. And at this point, it doesn't matter where our y-intercept is, because this line is always just going to be perpendicular to both of those lines, no matter where it crosses the y-axis. So we can just leave it at -1/2 x. So we want to find E first, and this is going to be the intersection between h of x, which is our perpendicular line, and g of x. So basically, we're just going to set h of x equal to g of x and find what x coordinate E lies on. So we have 2x minus 2 equals -1/2 x. And if we solve for x here, we get x equals 0.8. And we can plug this x back into either equation. So if we use g of x, say 2 times 0.8 minus 2, then we end up with -0.4. So our y is -0.4, which means our E is at 0.8 negative 0.4. And then similarly, we're going to define f as the intersection, this time between h of x, our perpendicular, and f of x, which was our original 2x minus 4. So again, if we set them equal to each other, 2x minus 4 equals negative 1/2 x. We come out to x equals 1.6. And then if we plug this back in, so 2 times 1.6 minus 4, then we get that y equals negative 0.8. So our f is at 1.6 comma negative 0.8. So now what do we do with these points? Well, we know that our height is the distance between E, F, and our base is the distance between B and C. So if we use the distance formula between B and C and the distance formula between E and F, we can define our B and our H and finally plug it back into our area equation. So let's put it over here. So E is at 0.8, negative 0.4, and then F is at 1.6, negative 0.8. Okay, so like we said, B is going to be defined as the distance between B and C. If we recall, the distance formula is equal to the difference between the x values squared plus the difference between the y values squared, and then square root of all of this. So the distance between B and C, we're going to do distance between B and C is 6 minus 0 squared plus 8 plus 4 squared. And then we can simplify this so it becomes 6 squared plus 12 squared. So this is the square root of 180. Then when we plug this into the calculator, we get that our base is going to be about 13.4164 units. Then we want our height, and our height is going to be the distance between E and F. So if we plug E and F into our distance formula, then we get it's 1.6 minus 0.8 squared plus negative 0.8 plus 0.4 squared. Square root of all that. And this comes out to square root of 0.8, which is going to give us about 0.8944. So this is our base, this is our height. We can plug these back into our area. And this gives us 11.999, which rounds to 12 units squared. So our area of this parallelogram bounded by all these lines is going to be 12 units squared.